Epinephrine is a hormone secreted into the bloodstream in response to physical or mental stress caused by fear or injury. It initiates many bodily responses, such as an increase in heart rate and an increase in blood glucose concentration.
Understand?
When someone reacts quickly and spontaneously to protect themselves from an oncoming threat, for example dodging a car that is heading their way, the cause of this reaction is not adrenaline, although most people would think it is. The reason why we humans can react so quickly is because of our nervous system. The signal from the brain travels extremely fast down the nervous system, which is attached to your muscles. Now, after an incident like this, you feel a certain rush. This is more commonly known as an adrenaline rush. Back in the day, now I'm talking way back in the day, all the way back to the prehistoric age, if you were attacked by a bear or a mountain lion or something of that sort, you either had to flee or attack the attacker. This reaction is part of the sympathetic nervous system and is called the fight or flight response. Your nervous system has everything to do with the release and the triggering of the hormone epinephrine. The hypothalamus sends a nervous signal down to the adrenal gland, where the adrenal medulla releases adrenaline into the blood.
Let's talk about the affected organs.
Epinephrine is a chemical signal that is attached to the circulatory system, which means it flows very quickly through the body. It doesn't actually enter the cells, but it binds to the surface of the cells, for example, the liver. The liver converts glycogen into glucose, which courses through our body and gives us that energy. When epinephrine reaches the lungs, it is going to speed up the breathing so that more oxygen can diffuse into the blood and so that more carbon dioxide can diffuse out. When it reaches the cells in the heart, it is going to speed up the heart rate in effort to get more oxygen to your muscles. Epinephrine causes organs like the large intestine, the pancreas, the small intestine, and the stomach to relax and decrease digestion in effort to move more blood to other organs such as the muscles. The release of adrenaline can also have other effects on various organs in the body. For example, the secretion of potassium and water in the salivary glands, as well as secretion in the sweat glands. Let us explore the chemistry of the making of adrenaline in the human body, otherwise known as biosynthesis.
The chemical breakdown of adrenaline begins with tyrosine, an amino acid obtained from food. The enzyme tyrosine hydroxylase breaks down the tyrosine to L-DOPA. L-DOPA is further broken down, with the help of dopamine decarboxylase, into dopamine, which is a neurotransmitter. Dopamine is found in only 4 pathways of the brain. Dopamine is broken down further by an enzyme called dopamine hydroxylase to form noradrenaline. Noradrenaline is also a neurotransmitter. Finally, an enzyme, phenylethanolamine, breaks down the noradrenaline into adrenaline, which is then secreted from the adrenal gland.
Epinephrine is composed of carbon, hydrogen, nitrogen, as well as oxygen, and its chemical formula is C9H13NO3. It has a molar mass of 183.204 grams per mole.
Adrenaline has several uses that have an impact on our day-to-day lives. It helps us in physical activities by giving us energy. Another important use of epinephrine that surely has saved many lives is its use in EpiPens.
The reason why the injection of epinephrine is the treatment of choice is because it works quickly and effectively to constrict blood vessels, relax muscles in the lungs, stimulate heartbeat, as well as reverse hives and swelling. Here's David explaining how to use an EpiPen.
Hold the EpiPen with the black tip toward your outer thigh. Now swing and jab the EpiPen firmly at a 90-degree angle into your thigh. Your EpiPen is spring-loaded and is designed to be used through clothing. Keep the EpiPen firmly against your thigh for approximately 10 seconds. Now remove the EpiPen and massage the injection site. In conclusion, we discovered that adrenaline is a very important hormone, from making you perform your best in sports to saving someone in a life-threatening situation. The presence of adrenaline in stressful situations is just another way that shows us why adrenaline is something that we humans absolutely cannot live without.